Okay, scatter diagrams 453 and 454. So I've put these two together, and these are the things that you need to be able to do on scatter diagrams. So first of all, what type of data? So a scatter diagram is where you've got a plot, just one cross, that corresponds to two pieces of information. So it could be, let's say, temperature, and then sales of ice cream. So let's say the temperature was, say, 25 degrees, then sales of ice cream would be quite high. That might be, I don't know, £2,000. If the temperature's lower, it might be £1,000. Okay, and it should be that there's some kind of pattern between the values. So it should look like that for this, for sales of ice cream and temperature. So types of data, well, it has to be numerical data. And generally it's to do with continuous, so temperature is one example. Money is another example. So age is another example. Correlation. So there are three types of question you could get on correlation, or three examples. So let's say we had something, I plotted two values. This would be positive correlation. In other words, as one goes up, the other one goes up as well. You could have that, which is negative correlation. As one increases, the other one decreases. And no correlation is where you can't see a pattern in between. So correlation is just another word for a pattern or a trend in the data. An outlier, well, that's something that sticks out. So here, there's a trend there with the values, but this one would be an outlier. Also, you could go to here, this one here would probably be an outlier. That means it stands out from the set of data. It doesn't follow the pattern. So as I said before, each point on here represents one person, one incident, one day, one car. So here this will be on a particular day. So the sales and the temperature on a particular day. So next bit, line of best fit. So this is roughly the best line that you could fit in the diagram. Doesn't have to go through 0, 0, so it doesn't have to go through there. And it doesn't have to join all the points together. So it could be a straight line that goes through the centre of the points. Don't join them up. Don't join as many points as you can up, roughly the middle of the data. So I could do one here that would be roughly like that. Again, watch, it doesn't cross through there, 0, 0. This one is an easy one. The closer they are together, the closer the pattern or trend. Interpolation. So this is where you're going to be given a piece of information and you use your diagram to find the answer to it. Extrapolation is where you go outside the range of data. So for example, if I wanted to hear a temperature that was past the end of the scale, say that was 30, so I wanted one that, what if it was 35 degrees? I couldn't use my set of data necessarily because you don't know what's going to happen at the end of this. So it could be here that it's too warm, people won't go out and therefore buy ice cream. So the line may not be straight past, and that's called extrapolation. So here's an example of a scatter diagram. That is the value of a car. So each one of these dots is a car. It's the value over a certain length of time. So as you would expect, it'd have the highest value at the youngest date or the least age. And that's generally what the trend you can see. So here, if you were going to put a line of best fit, you'd roughly go something like that. So what about how can we interpolate? So what if I said to you, I've got a car that's 2.5 years old. What would be your estimate of its value? You would go to 2.5, you go up to your line, you draw across, and you get about 64, and that value is 64,000. So what if you had a car that was, say, £45,000? What age would you expect it to be? 45, go across, and then go down. So that would be roughly, that's 5.5. So it's 5.2 years. And that's called interpolation.